Hello everyone, in today's lesson we're going to continue to talk about subtraction of the vectors. Okay, let's look at example 12. Okay, in the example 12, okay, this is example 12. So basically inside example 12, so we have one regular hexagon and O is their center. O is the center, okay. It's given AB equals to P, and then CD equals to Q, and then EF equals to R. So we're going to find out A and B. So what is this A? Let's look at A, right? A is identify the vectors which equals to the Q. Okay, so what are those vectors? Vectors. So find vectors equals to Q. Okay, so let's look at this. Regular hexagon. So how many vectors is equals to the Q? Okay, so from here we can see that. Okay, first one. Okay, let's say so Q equals CD is the Q. CD because this is the regular hexagon, right? Okay, so from here we can see that. Okay, let's first we see that. Okay. And CD equals to Q. Okay, so because A, B, C, D, E, F is a regular hexagon, right? So inside this, so we also can find out this. Okay, OCDE. Okay, OCDE is also a parallelogram, right? So okay, from here we can find out this. It's a parallelogram. Okay, so let's continue. Okay, so from here we can see that since we have this, so we can know that okay, CD is also equals to OE because they are all the parallelograms, right? So this CD equals to the OE, right? Okay, similarly, we also can continue. Okay, that's the same. Similarly, okay, so we also can find out, right? So what else? What else vectors also equals to the Q? Okay, we can find out, right? CD, we can find out, okay, the BO is also parallel to the CD. They also have same magnitudes, right? BO also equals to CD, right? So what else? Let's find out. And A and AI. So because this is also another parallelogram, right? So we have to find out that, okay, so AF is also equals to the BO. Hence they also equals to the CD, right? Okay, so what else we can find out? If let's say any other one, so 1, 2, so how about OE? You already find out. Okay, that means we have how many? We have 4, right? We have 4, right? We have 4, right? So we have CD, we have OE, we have BO, and we also have AF. So finally, how many we have? So if this is the case, so we can find out, okay, the OE, BO, and AF. They are all equals to the CD. They are also equals to the Q, right? So this is the answer, right? Okay, let's continue. The other one. Okay. So how about the R? So find the vectors. Find the vectors. Find the vectors equals to the R. So we know that. So E, F, they are equals to R, right? Okay. So in this case, because they are the regular, because A, B, C, D, E, F, A, B, C, D, E, F are the regular hexagon. So from here we know that. Okay. So and then we also know that O, E. Okay, because this is the regular hexagon. So from here we can see that. Okay, FODE, FODE. That is also okay. That's right here because the OA, because the O. So because OA, O, F, O, D, E, F, O, D, E is also a parallelogram. So from here we can see that. Okay, so from here we can see that E, F also equals to which one? This one also equals to this, right? Equals to the DO, right? That's also equals to DO, right? So continue. Okay, similarly, so we also can find out. Okay, the EF, apply the same concept. They are also equals to DO, also equals to CB, right? Because they are parallel and the same magnitudes. Okay. Now what else? How about OA? Same OA, right? To OA, right? So hence we can find out. Okay, the EFR also equals to the DO, CB, and OA, right? So hence the DO, OA, and CB, they are also equals to the EF and equals to the R, right? Okay, so this is very straightforward, right? Okay, this is A and B. Of course, we also have a C, right? Let's look at the C. Okay, let's look at C. C what? What I think we're going to find the C, right? In the C we have three items we need to find out. The first one we need to find out is to express P plus Q equals to R as a single vector. As single vector. Okay, so let's do that. Okay, P Q plus R equals to what? Okay, I say P because the P is here, right? P is A B plus Q is the C D, right? Then what's the R? R is the E F, right? So from here we can see that. Okay, so let's move. Okay, that is very important concepts that. Okay, we move all those vectors into a single triangle or a single parallelogram. Okay, so in this case, AB is what? So AB equals to AB equals, okay, in this case AB, we can move AB is equals to, okay, it's AB plus, okay, let's move the CD, okay. CD, we know that CD is equals to BO, right? Then EF equals to the OA, right? CD, OA. Okay, so here we change. When we change, we use different color. CD equals to the BO, right? And here EF equals to OA, right? Okay. So if this is the case, okay, OA. So use the triangle. So here this two just cancel off. So becomes OA. So what is that? That equals to the OA equal to OA plus AO plus the OA. So if this is the case, so this is two opposite vectors. So we cancel off each other. So we get AA. So in this case, it becomes 0, right? That's the same point. The point is A. Is here, right? That is the one. Okay, so if this is the case, so we can find out. Okay. So this equals to. So what's the answer? The answer is 0. Okay. Okay, let's continue. So the second one is to express the PQ minus B. Okay, so express P Q minus P as a single vector. Okay. So from here we can see that, okay, so because P, we can write P plus minus, because this is a typical subtraction, right? As this a typical subtraction, so we can write it in this way. So P equals to this. So from here we can see that Q is the CD, right? Then plus minus P is minus A B. So okay, now it's important. CD plus minus AB, right? Minus AB is what? So we change that. So minus AB, so become the DE, right? Right? Okay, so from here we use the same triangle. We cancel out the D, become CE, right? So this is the answer. Okay, so we will get. So in this case we get CE. Okay. Okay, right? CE. Of course, CE. So similarly, CE, from CE also we can get a BF. BF is also equals to CE, right? CE and BF. Okay. Let's continue. 3. Okay, so the next one. Express Q minus P minus R as a single vector. So because Q minus P minus R equals to what? Okay, so we can see that because P minus Q is really bringing it here. So we get C E, right? Then minus R. So what's R? R is the EF, right? R is the EF. So from here we see that CE minus EF. Okay. CE minus EF. So what belongs to EF. EF is actually is the CB, right? Okay. EF, CB. EF, CB. So then we also can change as plus BC, right? BC, CB. So from here, this triangle, apply the triangle law. What do we get? We get is the, because B, C, and C, okay, we just make it change, make it much more clear. So from here, we use the triangle law, we just cancel out the C, we get BE, right? BE is the result, right? Okay, that's very straightforward, right? Okay, so we get answer. The answer is the BE. So, okay, that's all for today. In the next class, we will continue to talk about example 13. Okay, thanks for watching. Bye bye.